harder, such as helping people affected by natural disasters. Ford's Silicon Valley team has been working with DJI, the leading maker of professional-grade drones. And we believe our vehicles and drones could make a really big difference if they were connected through sync. So Ford and DJI are teaming up with the United Nations Development Program to launch a developer challenge to create drone-to-vehicle communication software to improve response times in emergencies. Developers are needed to create ways to launch the drone from the bed of an F-150, survey the landscape with the drone's thermal imaging and mapping technologies, and find a way for the drone to communicate in real time using vehicle data available through Sync AppLink to locate the truck and actually dock itself in the bed, even if the truck has moved to a new surveillance area. And doing this will help the UN assist people afflicted by natural disasters and potentially save lives. The top prize is $100,000, and it'll be announced later this year. So now turning to mobility and driving innovation among startups. Today, we're announcing that the Ford-sponsored Techstars Mobility, driven by Detroit, is accepting applications from startup companies interested in developing future mobility solutions. Now, up to 12 companies will receive $120,000 and 3 months of training and mentoring to develop ideas and solutions in 4 key areas: the consumer experience, information technology and data analytics, multimodal trip integration, and flexible ownership and user experience. And the deadlines for submission is March 22nd, and the program is going to launch on June 13th, and then it'll wrap up in September. And we've seen a lot of great success from the first class of innovators that we sponsored last year, with 10 startups raising more than $3 million since completing the program. And finally, let's turn to autonomous vehicles. You know, there is a lot of talk out there, right? A lot of claims are being made, stunts are being performed, and future concepts are being shown. At Ford, we've been focusing on developing autonomous vehicles for more than a decade, because for us, it is very serious work. And you can see that in the millions of Ford vehicles already on the road with driver-assisted semi-autonomous technologies, and the increasing levels of safety and convenience that we deliver every year for our customers. Now, this is a stepping stone approach to fully autonomous driving, and it's the prevailing approach in the industry. But there's much more to Ford's autonomous vehicle plan. We're approaching autonomous vehicles with a dedicated research and development team working on fully autonomous driving, much like we're seeing from the technology companies. And this summer, in fact, we moved from the research phase of autonomous vehicle development to advanced engineering. And today, we're taking another big step forward in making fully autonomous vehicles a reality. And to share more details, I'd like to invite Raj Nair, our Chief Technical Officer, to join me. Raj? So today, we're announcing that Ford is tripling the size of our autonomous vehicle testing fleet, and we're accelerating our on-road testing to further advance our own self-driving or virtual driver software capability.
We'll have about 30 Fusion hybrid autonomous vehicles on roads and test tracks in California, Arizona, Michigan, including the all-new M-City, a simulated urban environment at the University of Michigan. This gives us the automotive industry's largest autonomous vehicle development fleet, accumulating miles in real-world testing and further honing our software.
You know, our expanded autonomous fleet will be actually our 3rd generation autonomous vehicle platform. If you look back, our first platform was based on an F-250 Super Duty pickup, which we used in the DARPA challenges in 2005 and 2007. In fact, Ford had the only factory-led effort in the DARPA challenges, and we were one of a handful of teams that participated in the final rounds. And the members of that team remain on our team. And this really helped us to define our approach to autonomous vehicles very early on, and we've stayed on that path. We learned things. We saw the importance of high-resolution 3D mapping, of real-time 360-degree scanning, using LiDAR technology, and then fusing that data with input from other sensors, including radar, camera, and sonar.
Our second generation autonomous vehicle platform was built using Fusion hybrid sedans and hit the road in 2013. This platform focused on two core elements: further development of the algorithms and sensor components. Sensors play a critical role in autonomous vehicle capability. They serve the same role as the five senses of the human driver. So that's why we've been working very closely with Velodyne on LiDAR technology for more than 10 years.
And today, we're announcing that we're equipping our third generation fleet of autonomous Fusion hybrids with the most advanced LiDAR from Velodyne, the new solid-state hybrid ultra-puck autosensor. And this is also Velodyne's third generation technology, and as you can see here, they've made significant progress in advancing the technology, especially in terms of the size.
You can see here on the stage the first generation LiDAR that we used on our DARPA challenge effort with the Super Duty. The second generation LiDAR in the middle is now installed on our Fusion hybrids, and we use 4 of them on every car.
And here is the all-new puck. You know, this all-new sensor technology is elegant in design, but it makes a huge impact in how it helps advance our autonomous driving technology.
They're named the Ultra Puck because they're the shape of a hockey puck and fit into the car's side view mirrors. They're developed specifically for automotive use, extending the sensor range by 200 meters versus the last generation. And these sensors provide even better precision, which is critical for mapping and creating accurate 3D models of the environment. Now let's talk about the word autonomous, which gets thrown around a lot without a lot of clear definition. We evaluate vehicle technology, autonomous vehicle technology, based on the SAE levels of automation. Most of today's automakers are at levels 1, 2, or 3, which we refer to as semi-autonomous, because the driver is required to be involved at some point in the driving process, like with Tesla's new autopilot system. Ford's autonomous vehicle program goal is delivering level 4 capability, which is full autonomy in defined environments. This is the level that technology companies are going for because it takes the driver completely out of the loop, which ultimately leads to level 5, which is full autonomy in any location and weather conditions.
Thanks, Raj. So, as you can see, we at Ford are very serious about autonomous vehicles as part of our holistic Ford Smart Mobility Plan. And when the first Ford autonomous vehicle comes out, it will not be just for those folks who can buy luxury vehicles. It will be an autonomous vehicle designed to serve millions of customers. Now, some of you may have been reading the news and asking if we plan to work with others as we develop our autonomous vehicles. And the answer is yes. We're already working with several universities, Velodyne, State Farm Insurance, and we'll continue to work with others, not just on vehicles for retail customers, but also on autonomous vehicles to provide transportation as a service. And that includes serving customers who might not own a vehicle in the future, such as the young, the elderly, or those looking for an alternative to mass transit. And I can assure you we'll share more news on our work on autonomous vehicles as we continue to make progress. So there you have it.